Welcome to another Jenny Science tutorial. In this video we will show you an example programming of a pick-and-place system with the master-slave function of our XENAX servo-controllers. Our pick-and-place system consists of a Linux LXC 135F10 as x-axis, a Linux LXC 80F40 as c-axis, and two XENAX servo-controllers. In order to complete a programming with the master-slave function, you additionally need a master-slave USB cable to connect the servo controllers. It is up to you to choose which controller should be your master and which one should be your slave. You only need to plug in the cable according to your choice. The master-slave function allows up to 4 XENAX servo controllers. To get started with the programming, I would like to introduce our application with a handmade sketch. The X and the Z-axis build the basic frame. Our x-axis has a maximal stroke of 135,000 increments, which corresponds to 135,000 microns. And our c-axis has a maximal stroke of 80,000, which corresponds to 80,000 microns. We want our starting point for the x-axis to be at 30,000 increments and for the c-axis at 5,000 increments away from the mechanical zero. Our first command will therefore be to move the x and the z-axis to their starting positions. Then we start with the actual application. We move the x-axis to the absolute position of 130,000 increments. Then the z-axis starts its motion to the absolute position of 75,000 increments. When this target is reached, an imaginary gripper will be closed and the z-axis moves back upwards to the absolute position of 5,000 increments. Then we want the program to bring the x-axis back to its original position of 30,000 microns, where the z-axis moves down to 40,000 microns and releases whatever is in the gripper. Please note that these red arrows indicate that certain motions begin before the previous motion has ended. So at some points we have both axes moving at the same time. The first step is to set up our controllers. We first enter the TCP/IP address of the slave controller in our web browser window, which in our case controls the x-axis. To keep an overview of our controllers, we set the controller card identifier to 1, with CI1 in the menu Move Axis by Command Line. With CI question mark, the controller tells you the assigned number. If you have more than one slave, each slave needs a different card identifier number. Then we define the payload of the x-axis, which in this case is 50 gram, simulating a gripper or some similar application. Save those settings to the controller with Save to XENAX. Then we switch to the master controller, which controls our z-axis, and repeat the setup steps. It is important that you always assign the card identifier number 0 to the master controller. Next, we enter the payload of the z-axis, which in this case is the 50 gram on the x-axis plus the x-axis itself of 880 gram, totaling to 930 gram payload on the z-axis. Now we are programming the application by identifying our 5 different indices. An index is a position profile which contains acceleration, speed, and distance. Let's first define our indices for the z-axis. These are all the blue values on our sketch. The first index moves the z-axis to position 5000. We set an acceleration of 35 million, which corresponds to 3.5 g, and a speed of 1.2 million, which corresponds to 1.2 meters a second. We then enter the target position of 5000, which corresponds to 5 mm away from the mechanical 0 point. Under type, you can choose to enter relative or absolute distances. However, we strongly recommend to use absolute positioning as used in this example. Because the measuring scale is precisely adjusted to the mechanical moving range, the advantage is that you don't need to calculate relative distances and moving directions. We copy the data of index 1 into index 2 and only change the distance. This will move the z-axis to the absolute position of 75,000 microns at the same speed and acceleration as in index 1. We also enter the data for the last index of the z-axis, index 3, and since we want the z-axis to move evenly for all motions, we only adjust the absolute distance to 40,000. We proceed similarly with the x-axis. In order to keep the x-axis and the z-axis apart, we assign two-digit indices to the x-axis. We begin with index 11 for the first motion of the x-axis at an acceleration of 5g, a speed of 2 meters a second, to the position of 30,000 increments, which corresponds to 30 millimeters away from the mechanical 0 point. We copy this data to index 12, keep the dynamics the same as in index 11, and adjust the distance to 130,000 increments. Now we have the raw data together to write the program. The programs can be simply written line by line. We open the program number 1 and begin by referencing both lineamotors. LOC means we reference the local controller, which is our master controller. For the reference of our slave, we choose the device with the ID 1, which is the card identifier we have defined earlier. By the way, you can determine the direction of the reference motion in the menu Setup, Reference. Going back to our sketch, we will find the starting point. It corresponds to index 1 for the z-axis, which belongs to our master controller, and the index 11 for the x-axis, which belongs to our slave controller with the ID 1. After we have set the lineamotors in the correct position, we would like to wait 1 second and include the according command in our program. Now we are ready to program the actual pick-and-place process. We set index 12 for our slave controller that orders the x-axis to move 230,000 increments. With the 60%, we indicate that after 60% of the distance of index 12, the program begins the next line, while at the same time index 12 continues to its end. As a short reminder, these kind of shortcuts are indicated by the red arrows in our sketch. As a result, we have a more efficient motion profile, which saves cycle time. Next, we set the z-axis in motion to 75,000 increments with index 2. The output 5 simulates an activation of a gripper. The 50 milliseconds wait time makes sure our program is not moving while the gripper is activated. A good idea is to make sure that the gripper is open before starting the pick-and-place procedure. In the web motion programming, it's no problem to insert a line into the existing program. All you need to do is to choose the position, set the command, in our case clear output, and hit insert instead of set, and the command will be added to the chosen position. We then set index 1, which moves the z-axis back up to 5,000 increments, and with index 11 we move the x-axis back to 30,000. Again, the percentages for these indices result in the beginning of the next programming line, while the current is still ongoing. The z-axis moves then down to 40,000 increments with index 3. Reaching this position, we deactivate the gripper with clear output and enter a wait time of 50 milliseconds. Then, we move the z-axis back up to the starting position with index 1. Now we have programmed one full cycle, and with the command go to line 7, we create an endless loop. Before we can see the whole application in action, we have to download the program to our master XENAX servo-controller with saved to XENAX. And in order to keep the application's dynamic in check, we reduce the speed with the speed override. Under the menu Move Axis by Command Line, we can start the program and test its functionality by entering PG1, which stands for Program 1. And here we go! In about 10 minutes we have programmed a new pick-and-place system. With the speed override, you can easily adjust the program's dynamic while the application is running. For practical use, it could be interesting to start the pick-and-place cycle with an input function. We therefore split initialization and actual application in two different programs. For reasons of simplicity, we first copy program 1 to program 2. Then, we delete all application commands in program 1. In our example, these are all the commands that come after the reference and the setup of the starting position. Then we delete all initialization commands and the command for the automatic repeatability in Program 2. Under Application I/O, we add Program 1 to Input 1 and Program 2 to Input 2. We also set outputs to indicate the end of the program with EDPG and to indicate errors with ERR. And again, we save the program to our XENAX servo-controllers with Save to XENAX. And here comes the final test with the I/O box. And you see, ladies and gentlemen, programming with our XENAX servo-controller has never been easier. And as a last step, you should not forget to save your pick-and-place application to file for future use. You are more than welcome to contact us if you have more questions to the programming of your XENAX servo controllers. Thank you for your attention.